I'm Anil Kumar, and in this video we will learn how to solve trigonometric equations when the angle is not just x but it could be 2x, 3x, 1/3 of an x and things like that. So let me take some examples to describe what I'm saying, right? So it is, let us say we have 2 sine x plus 1 equals to let us say equals to 2. Now how do you solve this equation? Now if I change this equation a bit, and instead of making it 2 sine x, if I change this equation to, let us say, 2 sine 2x plus let us say square root 3 equals to 0, then how am I going to solve this equation? And what we will consider in all our examples is that x is greater than equals to 0 and is less than equals to, let us say, 2 pi, right? So we'll work in radius. Let us say that is the domain in which we need solution of these questions. We could have had a question like square root of 2 cos, let us say, 1/3 of an x is equal to 1, and we may have to find solution of this equation in the given domain. So does it have a solution or not in the given domain? So that is what we'll try to figure out with the help of these examples. So the first one is 2 sine x plus 1 equals to 2. We can actually solve this. We as 2 sine x equals to 2 minus 1, which is 1, and so we have sine x equals to half. And as you know, sine x is half a positive value in two particular quadrants. Sine is positive in quadrant 1 and also in quadrant 2. Now to find the value in radians, we know we can use special triangles for sine. So we have a special triangle which is pi by 3, pi by 6, where this angle is pi by 3 and the sides are 1, 2, square root 3, right? Now you're looking for sine to be half. That means that angle, which should be pi by 6. So the acute angle which we are looking for is pi by 6. So this angle is pi by 6 for us. So the acute angle is pi by 6. So sine x is positive in these two quadrants. So within 0 to 2 pi, we have two solutions, and we can write down our solutions as answer x is equal to pi by 6. That is one answer. And the second value will be this much, right? So that's the principal angle, which is 5 pi by 6. 5 pi by 6. So we get two solutions from the first equation. Now let us simplify and find the solution from the second equation. Now the second equation is kind of different. It is 2 sine 2x plus square root 3 equals to 0. So let's rearrange this equation. If I rearrange, what do I get? I get 2 sine 2x equals to minus square root of 3, or we get sine 2x equals to minus square root 3 over 2. Now the argument here is not x, but it is 2x. We know x is between 0 to 2 pi, so 2x should be between what values? We'll multiply both by 2. So we get 0 to 4 pi. So that becomes now the domain for 2x. That means two circles. Do you get the idea? Now, square root 3 over 2 for sine theta, the acute angle, we are looking for negative this time. So the negative solutions means that we are looking for solutions in quadrant 3 and in quadrant 4. In these two quadrants, sine is negative. And the acute angle, square root 3 over 2, that means pi by 3. So the angle which we have here is pi by 3. So this angle is pi by 3. The acute angle is pi by 3. Now what are the possible angles within that domain 0 to 4 pi, that means 2 circles, okay? So that is 2x equals to, so we get 2x equals to, if we go first round, let me take another ink here to show you the solutions. First one will be this much angle, right? So that is pi plus pi by 3, that means 4 pi by 3, right? So we have 4 pi by 3, and then another this much more. So that is 1 pi by 3 less than 2 pi. So that value will be 5 pi by 3, right? And then we have to go one more round, correct? Since the domain is for 2x, not x. That is the kind of thing which we have to work with, right? So we have to add one more round. So we'll add 2 pi to them. If you add 2 pi, 3 times 2 is 6, 6 plus 4 is 10. So we get 10 pi by 3, and 6 plus 5 is 11, 11 pi by 3. So these are 4 solutions for 2x. What is x is equals to? X is equals to, you need to divide them by 2. So when you divide by 2, you get pi by 3 here. Divide by 2, you get 5 pi by 6. Divide by 2, you get 5 pi by 3. And divide by 2, 11 pi by 6. You'll note these answers of x are within your domain. Do you get the idea? So when you change the argument, for example, in this case we change it to 2x, you have to also change the domain, right? So that is how you should be solving such questions. Now this question is for you to solve. Here, of course, you can simplify and you can write this as cos 1 over 3x as equals to 1 over square root 2, right? Now when you have 1 over 3x, then this domain changes to 1/3, right? And as far as the acute angle is concerned, you know it is pi by 4. So if you divide this by 3, so you get what? Your domain changes from, so x over 3 is less than 2 pi by 3. You get the idea? 2 pi by 3, right? So basically your domain has got restricted, and so you're looking for solutions of this within the domain 0 to 2 pi by 3. So this is like 0, this is pi by 2. 2 pi by 3 means kind of up to here, right? Now cos 1 over 3x equals to 1 over square root 2. We do have a solution for this, and that is at pi by 4, right? So you could write that 1 over 3x is equals to pi by 4, correct? For cos pi by 4 you get 1 over square root 2. Now we cannot consider the angle here in quadrant 4 since our domain has got restricted to just 2 pi by 3, right? So from here we can say x is equals to 3 pi by 4, cross multiply. So we get one solution for this particular question. The idea to share with you is that when the arguments change, in that case the number of solutions also change. So when it was just x, we had 2 solutions. When it was 2x, we had 4 solutions. And when the argument changed to 1/3 of an x, we had just one solution. The reason is that within 0 to 2 pi, we had a wave which was 1/3 of cosine wave, right? And therefore 1 over square root 2 was only for one particular value of x, which is 3 pi by 4, right? I hope with this you understand the concept, and it helps you to solve questions where the domain could be changed since the argument is different. I hope that helps. Thank you.